Okay, these are the solutions for your third exam that you just took. So this was question number 1, and you needed to find k so that this would be continuous. So step 1 is to say f of 4, which is k, and then the limit as x approaches 4. You'll use the first function, factor. Those cancel, and you're just left with x plus 4, and then you can substitute 4 in there, and you get 8, and that was choice D. Okay, question number 2 was a simple limit problem. So you can't substitute because you'll get 0 in the denominator, so instead you'll factor the numerator. And then the x plus 2's cancel, and now you can substitute. And that gives you -7, and that was choice B. Okay, question number 3. This was a limit as x goes to infinity. So you need to look to see where is the highest exponent located. There's a 2 in the numerator, a 2 in the denominator, and therefore you just have to take the coefficients. So it's a 1 over -4, and that was choice B. Okay, problem number 4. This is a simple quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. That was not a choice, so we have to simplify. So all you have to do is distribute this 2 and distribute that 3. So that's what I'm going to do. And I get 6x plus 4. I'm going to take this negative with that 3. So a -3 times 2x is -6x, and a -3 times +3 is -9. These 6x's cancel, and we're left with -5. And that was choice D. Okay, this is number 5. This is going to require a product rule, but first you're going to have to rewrite it. So you're going to treat this as a product rule, which means that it's going to be this times that. Okay, so it's the first times the derivative of the second. That's going to require a chain rule. Bring down the 1/2, keep the inside. 1/2 minus 2/2 is -1/2 times the derivative of the inside. So it's the first the first times the derivative of the second plus the second times the derivative of the first, which is just 1. You could write that or not write that, it doesn't matter. So we need to simplify this because this doesn't look like any of the choices. So we have a 4x on the top. This goes on the bottom. Okay, and I'm putting that over 1 to find a common denominator. And the common denominator will be this. Okay, so my new fraction is just going to be this times this. Okay, I'm going to erase this part up here so I don't have to go to the next page because then you won't see what I did. Okay, so we're going to combine those numerators. So we get 4x plus, and now when I multiply this, I just get 2 times 4x minus 1. And they share the same denominator. Okay, now I'm going to distribute that 2. Four x plus 8x is 12x. And that doesn't match any of the choices either. So now I'm going to look at my numerator and recognize that that can be factored by pulling out a 2. Now these 2's cancel. And I'm left with that, and that was choice A. Okay, this is number 6, so first we need to find the derivative. So we have to bring that 4/3 down to the front. And 4/3 minus 3/3 is 1/3. 4 times 5 is going to give me 20 over 3, x to the 1/3. So that's the derivative, but you were asked to find the derivative when x is 8. So I'm going to substitute in 8 there. Cube root of 8 is 2, and I get 40 over 3, which was choice B. Okay, so this is number 7. This is going to require a product rule, but we're just going to change the form a little bit first. So just keep in mind that it's going to be this times that. Okay, so it's the first times the derivative of the second plus the second times the derivative of the first, which is going to require a chain rule. I'm going to run out of room, so I'm going to put it here. Okay, so bring down the 1/2, keep the inside. One half minus 2/2 is a negative 1/2. And then we need the derivative of the inside. Okay, and you could clean this up, or you could just substitute 0 in for x, because we're really looking for f, whoops, sorry about that, really looking for f prime of 0. So I'm just going to put 0 in there, because I think that's going to wipe a lot of stuff out. So if I put 0 in there, I get 0. I put 0 in here, I get 0, and I'm just left with 121. Okay, if I put 0 in there, I get 2 times 0, which is 0. 0 plus 1 is just 1. Plus. Put 0 in here, put 0 in here, and I'm just left with 11. Okay, I'm going to carry down that 1/2. That gives me 0, that gives me 0, and I just have 121 to the negative 1/2. And then if I put 0 in there, that just becomes 0, and I have a 5. So now I just have to work this out. So square root of 121 is 11, and 11 times 1 is just 11. Plus 11 times, we have a 5 over 2 radical 121. So we have 11 plus 11 times 5 over 2 times 11. That gives me 11 plus 11 times 5 over 22. But now, this 11 can cancel twice into there. So I really get 11 plus 5 over 2. Find a common denominator. And I get 27 over 2, and that was choice B. Okay, this is number 8, and we're looking for an asymptote of x equals 1. So if you think about a graph, when x equals 1, we're looking for an asymptote like that, which means it's a vertical asymptote. So you're looking for when would 1 be a problem in the denominator. Okay, if you look at A, so what if 1 is x? It doesn't matter. B, there is no denominator. For C, if I put 1 in my denominator, I get 1 minus 3 plus 2. That equals 0. So C is definitely a problem. D, there is no denominator. And if I look at E, I put 1 in there, I get 1 minus 1 equals 0. So it's between C and E. So, but keep in mind, it's only a vertical asymptote if it doesn't cancel, because then it's a removable discontinuity. So for E, if you look at the numerator, that can be factored to this. Sorry, I don't even know what I'm doing here. Hold on. Okay, so let's see. My numerator can be factored to x minus 3 and x minus 1. That gives me a positive 3 and a negative 4x, and I get it over x minus 1. And so the x minus 1's cancel, which means that E has a removable discontinuity. So if that has the removable discontinuity, I'm going to go back and I'm going to look at C, and even if the denominator factors, how is it ever going to cancel with a 5x? And that's why C should be the answer for question 8. Okay, this is number 9, and you're just supposed to find out when is this not continuous. So we set the denominator equal to 0, and we get x equals 2, and that was choice A, and you're welcome for that question. Let's go on to number 10. This one was a little bit tricky. Okay, so for number 10, remember this is not as x is going to infinity. So if you wanted to break it up into two different limits, just to kind of see what's happening. This first one, that's just the limit of a constant, and that would just give me 2. But this one over here, that's a problem because x could never be 0. So how am I going to add 2 plus it does not exist? So if you actually look at the picture of this, it will look like this. And so you can see that as you're approaching 0 from the left side, that's this way, you're going up to infinity. As you're approaching from the right side, you're going up to infinity, and therefore the limit is infinity, which is C. Okay, moving on to number 11. We needed to find vertical asymptotes, so we take the denominator, we set it equal to 0. Okay, we get 2 discontinuities, but now we have to see does anything cancel. And that cancels. So when x equals negative 1, that was removable. And when x equals 1, that's the vertical asymptote. So that would be choice C. And finally we have number 12. Okay, and there are 3 different things that we have to find here. So we're going to check each one and see if they're true or false. Okay, so I'm going to start with the first one, which is it continuous at x equals 2? So the first thing we have to do is g of 2. Okay, so I can't substitute 2 into the denominator or I'm going to get 0. So maybe I could factor, if this is what you were thinking. Okay, and that one would cancel. However, even if that cancels, that just means that there's a removable discontinuity at x equals 2. But in the original, x can never be 2, so it's discontinuous there. So 1 says it is continuous, that's false. Okay, number 2 says there's a vertical asymptote at x equals -3. So if we take the denominator and set it equal to 0, and we already know we can factor that, we get x equals -3 and x equals 2 for the discontinuities. We already know that x equals 2 is removable because we found that back here, so that can't be the vertical asymptote. And if you look at your numerator and denominator, here's the numerator, and your denominator is this. There's no way that that x plus 3 is going to cancel out. So 2 is true. There is a vertical asymptote at x equals -3. Okay, I'm going to erase some of this mess here. Carrie Luna, I know this messiness is driving you crazy. Okay, and finally, the third one says there's a horizontal asymptote when y equals 0. So for horizontal asymptotes, you just need to look at where is the highest degree, and in the numerator, it's really x minus 2 squared, which is the same thing as x minus 2 times x minus 2, and that gives you x squared minus 4x plus 4. So that's my numerator, and my denominator is this. So all we have to do is look at the highest degree. There's a 2 in the numerator, 2 in the denominator, and therefore we're going to follow that rule that just says to take the coefficients. So there's an invisible 1 there, there's an invisible 1 there, and 1 over 1 just equals 1. So there's a horizontal asymptote at y equals 1. But choice 3 is saying that the horizontal asymptote is at y equals 0. So that is false. So the only one that is true is number 2, and that was choice B. And that's it. We're done.